Here we'll solve the questions from laws of machine chapter. So here I will solve two questions. So first question is, what load can be lifted by an effort of 120 Newton if the velocity ratio is 18 and the efficiency of the machine at this load is 60%. Next, determine the law of machine if it is observed that an effort of 200 Newton is required to lift a load of 2600 Newton. Find the effort required to run the machine at a load of 3.5 kilonewton. So we will solve these questions. So here first it is asked that we have to find out the load when effort is 120 Newton and velocity ratio is 18 and efficiency is 60%, that is 0.6. So we know how to find out how we can find out the load. So what is the value of efficiency? It is mechanical advantage by velocity ratio, that means W by P, that is load by effort divided by velocity ratio, that means 0.6 equal to W by 120 divided by velocity ratio is 18, that means 0.6 equal to W divided by 120 into 18, that means W equal to 0.6 into 120 into 18, that is 6 by 10. One second, I will check the answer. That is 1296 Newton. Next it is asked that determine the law of machine if it is observed that an effort of 200 Newton is required to lift a load of 2600 Newton. So it is mentioned that when the load is 2600 Newton, when W1 equal to 2600 Newton, that times effort required is P1 equal to 200 Newton. And for the same machine we have found that when W equal to 1296 Newton, that time the effort required is 120 Newton. So here to find what is the laws of machine, it describes the relation between the load and the effort. So we have already discussed about it. So P equal to mw plus C, where P is the effort required to lift a load, W is the load to be lifted, C is the y-intercept, that is the machine friction, and m is the slope of this straight line. So here we have to find out the equation. So for here two variables are given, so two equation we will found, then from there we will found two unknown. So we will solve it. So P equal to mw plus C, that means when P equal to 2600 Newton, that is equal to m into W equal to, that time W equal to 200 plus C. Similarly, when P equal to mw, P equal to mw plus C. Similarly, it is 120 equal to m into 1296 plus C, that is 120, I guess. For 120 Newton, effort is 1296, and for 2600 Newton, effort required is 200. So I'll solve this two equation. So minus CC similarly got cancelled. Then this is 80 equal to m into 2600 minus 1296. So m equal to 80 divided by 2600 minus 1296. So I'll check the answer. So after solving, I found the value of m is this one, 0.061349. Then we'll put the value of m in any one of the equations. So I put it in the first equation. So here 200 equal to m, that is 0.061349 into w is 2600 plus c. So we found the value of c. So we'll put it in the law of machine, that it implies p equal to m, that is 0.061349 into w plus c. C value is 40.492. So here we got the law of machine for this particular case. Next, what it is asked? Next, it is asked that find the effort required to run the machine at a load of 3.5 kilonewton. So it is asked that when load equal to, that is W value equal to 3.5 kilonewton, that is 3500 newton. That time I have to find the effort, that implies P equal to 0.061349 into W, that is 3500 plus 40.492. So that will be the answer. I'll check the answer again. So the answer is 255.2135 Newton. Next we'll solve the second question. It is asked that in a lifting machine an effort of 40 Newton raised a load of 1 kilonewton. If the efficiency of the machine is 0.5, what is the velocity ratio? First we have to check the velocity ratio. It is given that P equal to 40 Newton, W equal to 1 kilonewton, that is 1000 Newton. Eta value is 0.5. We have to calculate the velocity ratio. So eta equal to mechanical advantage by velocity ratio, that is equal to 1000 divided by P, that is 40, that divided by velocity ratio, that implies 0.5 equal to 1000 divided by 40 into velocity ratio, that implies velocity ratio equal to 1000 divided by 40 into 0.5. That implies velocity ratio is 50. So it is again asked that if on this machine an effort of 74 Newton raised a load of 2 kilonewton, what is now the effort, now the efficiency? So in this question it is asked that effort, when the effort is 74 Newton, that time load is 2 kilonewton, that is 2000 Newton. So velocity ratio will not change, so velocity ratio is 50. That time it is asking the efficiency. So 2000 divided by 74 divided by 50, that is the efficiency. I'll check the answer. 2000 divided by 74 divided by 50,